What I'd like to do now is demonstrate how to use Stata to conduct a multiple regression analysis. And the data that I'm going to use for this example, I've taken from the high school and beyond data set. And the subset of data that I have here is SAT math scores, math achievement scores, algebra 1, and motivation scores. And so the idea behind this example is to investigate how general math achievement, one type of math course, and motivation explains or predicts scores for scholastic aptitude mathematics achievement. So the first thing I like to do is look at the correlation between these variables. So we can go to statistics, summary and tables, summary of descriptive statistics, and we can go to pairwise correlations. And so I'm going to pick all those variables, and I want to know the number of observations in each, but more importantly I want to know the significance level. And then I could submit that, and we can toggle over to this output, and what we can see is that math achievement is highly correlated with scholastic aptitude math scores, and it's highly significant. Algebra 1, the correlation's not near as strong in magnitude. It's approaching a moderate correlation, but it's significantly related. Motivation is even smaller than Algebra 1, and it's still significantly related. So let's see what the results of our multiple regression analysis are. So you go to Statistics, Linear Models, and Linear Regression. And then our dependent variable is SAT Math, and our independent variables are Math Achievement, Algebra 1, and Motivation. So then we'll go ahead and click on OK, and we get our output. And so this is our Anova Summary table, and this is the variability that's explained by the model, by the three independent variables, that is math achievement, algebra 1, and motivation. So this is the variability that's explained in scholastic aptitude math scores by these three independent variables. And the residual is the error. That's what's left over. That's the unexplained variability. The analysis, of course, is significant. So that means that this linear combination of these three variables is explaining math achievement for the scholastic aptitude test beyond chance levels. Then we have our R-square, which means 62% of the variability in scholastic aptitude math achievement scores is explained by these three variables, or this linear combination. Then we have the adjusted R-square. The adjusted R-square is R-square that's then modified or adjusted for the number of predictor variables. So the more predictor variables you add to the model, the more R-square is adjusted, because when you add lots of independent variables, some of them are just not going to be very good in explaining the dependent variables. So this R-square adjusts for that type of error. So if we come down to our coefficients table, we can see that math achievement is significant. So it's significantly contributing to R-square, or explaining scholastic aptitude math scores. Algebra 1, however, is not significant, nor is motivation. So our most important variable here is math achievement. It's kind of surprising that one of the other variables is not significantly contributing. Okay, now keep in mind that even though these aren't significant, they still contribute to the variability in scholastic aptitude math scores. It's just that they're not contributing significantly. So they're still important pieces of the regression analysis that we need to consider when not only interpreting, but when forming a regression equation.